Hi, my name is McKenna Blaney. Today, me and my team of scientists are going to be talking and learning about a disease known as maple syrup urine disease. MSUD is an autosomal recessive metabolic disorder affecting branched-chain amino acids. A change in a person's DNA changes the body's ability to process 3 key amino acids. This disease gets its name from the sweet, distinctive odor of infant's urine. And now we're going to be learning about the biochemistry of this disease.
MSUD is a genetic disease caused by a mutation of an individual's DNA. This portion of DNA codes for the production of a protein called branched-chain alpha-keto acid hydrogenase complex lipoamide acyltransferase. This protein is responsible for breaking down leucine, isoleucine, and valine, the 3 amino acids. When the protein is unable to perform its job, the protein cannot break down amino acids, and it causes the buildup of them in the blood. To gain a better understanding of how this happens, let's first look at how proteins are made. Protein synthesis is the process that cells go through to make proteins. It starts with transcription in the nucleus, where RNA is created after reading one side of the DNA. To read that one side, the DNA unzips itself, and then one side is read. Once read, T goes with A, C connects with G goes with C, and A goes to U. Amino acids are formed by codons that make polypeptide chains, which are strings of amino acids. Uracil is the base pair that replaces the pairing of thymine in RNA. After transcription, translation starts in the cytoplasm, but more specifically in the ribosomes, where sets of 3 letters in the mRNA or codons makes certain proteins and sets of 3 letters of tRNA, which carries amino acids from the cytoplasm to a ribosome to help then create a growing protein. Maple syrup urine disease can be caused by homozygous or by a compound heterozygous mutation in at least 3 genes: BCK-DHA on chromosome 19q13, BCK-DHB on chromosome 6q14, and DBT on chromosome IP21. They provide instructions for making proteins and can reduce or eliminate function of the protein complex. It prevents the breakdown of leucine, isoleucine, and valine. They build up in the body over time and are toxic to the brain and other organs. This eventually causes health problems and even death.
These symptoms are mostly caused at the cellular level. Maple syrup urine disease is an autosomal recessive metabolic disorder affecting branched-chain amino acids. It's one type of organic acidemia. The condition gets its name from the distinct sweet odor of affected infants' urine, particularly prior to the diagnosis and during times of acute illness. It's a rare genetic disorder characterized by the deficiency of certain enzymes required to break down and metabolize the 3 branched-chain amino acids: leucine, isoleucine, and valine. The cells that cannot break these down are all affected in the body. And now here's the story of a young boy with maple syrup urine disease. Grayson McGill is just 2 years old and has been to the hospital multiple times to try various treatments. Now let's watch his story.
Grayson is a happy, active kid, but at only 2, he's already spent more time in hospitals than most of us. He had open heart surgery at 4 days old and suffers from maple syrup urine disease, meaning he's missing an enzyme that deals with excess protein, something that would be toxic and deadly if left untreated.
1, 2, 3. Good.
Good job.
So we have to give him the perfect amount of protein every day. That's the exact amount that his body needs for the day with 0 overage. So we measure protein to 2 decimal places.
Good job.
He has his blood analyzed at least once a week. Last year, he had his blood analyzed 62 times at the hospital. And then those numbers are rolled to his dietitian and to his metabolics doctor. So we use databases and spreadsheets to figure out how much banana or peas or yams to put on a scale to feed him. He can't have a gram more or a gram less.
I am Nora and I'm a scientist here, and I will be talking about possible treatments and cures for MSUD. Although there is no known cure for MSUD, Patients are given specific treatment plans and diets of what they can and how much what they can eat. The diet of someone with MSUD must be low in leucine yet enough for growth. It must also supply isoleucine and valine but be low in protein. Supplements can be used to fulfill each of these dietary needs.
Hi, I'm Sherry. I'm one of the scientists here. Grayson's story demonstrates how life could be affected with MSUD. Grayson's parents may have to measure how much protein Grayson intakes a day to make sure he doesn't have too much or too little. Although it was unexpected for Grayson's family to find that he had MSUD, this was quite possible because it is an autosomal recessive disorder, meaning that both parents passed on one recessive allele for the disease. Somewhere along in the family's genetic history, there was a mutation on one of 3 genes. Either the gene BCKDHA on chromosome 19, gene BCKDHB on chromosome 6, or gene DBT on chromosome 1 got the mutation. Grayson's alleles for this disease were too recessive and not masked by dominant allele. Therefore, Grayson has inherited MSUD. Now here's McKenna demonstrating Punnett.
Here are the possible genotypes for carriers of this disease and people who have the disease. Here's a Punnett score for homozygous dominant and homozygous recessive for the disease. All 4 offspring have the chance of passing on the disease to their child. This is a Punnett score for 2 heterozygous for this disease. This is probably what happened in Grayson's case. As you can see, both parents carried the recessive allele, therefore probably passing on to Grayson, like in this offspring. And finally, you have someone with the disease, 2 recessive alleles, mixed with someone who's heterozygous for it. As you can see, half their offspring have the disease, and half of it only have 1 allele. And that's everything on the genetic disorder maple syrup urine disease. We hope you learned a little bit more on how this genetic disorder works in terms of its biochemistry, hereditary, and DNA. The more we learn and research this disorder, the more we can hope for a cure. This was 60 Minutes. Thank you so much for watching.
Thanks for watching!
Sponsored by Msud.